Alrighty, hey everyone, my name is Rishik and I, and I'd like to present to you my project, Breaker. First, I'll be going over a quick overview as to what exactly Breaker does. Then I'll go into a code analysis on how the code works, and then I'll give you a demonstration of the project in action. First, the overview. Do you or someone you know spend way too much time on a computer screen? Well, if so, then this project is for you. Breaker is a code that uses artificial intelligence to help the user mitigate their usage time. And how it works is it detects a face using your web camera, and if there's a person in front of it, it'll start a counter going upwards. It counts both the total number of frames and the time that your face appears in it using AI to detect how long the user has been in front of the computer. And what makes it different from things such as screen time is that it actually tracks when the user is in front of the camera rather to how long your screen has been open. That's basically how the project runs and what exactly it is. Now we'll be moving on to the code analysis. All right, the code analysis. Let me open GitHub real quick. All right, so this is my GitHub for this specific project in this repository. You can find it, it's public. And here's our README. I recommend reading through it. It teaches you how exactly it works, what you need for it, the materials, my inspiration, and the different types of files I used. For this project, I initially was using the Jetson Nano, which is a $99 computer, which you can buy from NVIDIA. And it's specifically designed for artificial intelligence. However, there are a couple of drawbacks to it, such as the cost of it. And then there's the flashing of the SD drive and then installation of all your packages. And that took way too long for me, at least. So I decided to make it more accessible and create a generalized version, which I call Breaker Zero. And Breaker Zero can be run on any computer, regardless of anything, as long as you have your computer, a webcam, and a speaker, which is also optional, but it is for voice reminders. And I'll be going over both of them in today's video. So yeah, let's just get into it. First of all, I'll start off with the Breaker Nano, since this was my initial project. You have to connect it to the Jetson Nano using either headless setup, which is SSHing into it from a normal computer, or using the monitor setup, which is with an HDMI cable, an HDMI display, and speakers, Wi-Fi, and a lot more. So that's why, due to all those wire difficulties and technicalities, I recommend using the Breaker Zero if you're just using it for casual use. But if you do want to learn how the code works, then I recommend using the Jetson Nano version, because it's only 94 lines long as opposed to our other one, which is almost 200 lines long. Now we went over a brief overview as to how exactly it works. I'll get into the actual code now. For the Jetson Nano version, we have our basic imports here, CV2 for the camera, time for how long you want to spend on the computer, NumPy as just a generalized package, Adafruit, which detects and tells us the tilt and pan of our AI. We have this IPython.display mainly just for the audio. These were used in the Breaker Zero version. I imported that. We have GTTS for the text to speech, and we have our system notes. How it works, here are the camera constants, and here's the tilt constants. And the user can set the amount of time they want it to run. The default is 20 minutes. However, for today's demo, I'll be using it for 2 minutes, just for convenience sake. I do not want to sit in front of the computer for 20 minutes just for like the demonstration. So I will sit in front of it for 2 minutes and then show you how the program works for the demo. The end time is calculated by calculating the current time, which is given by time.time, which specifically gives the time since like January 1st of 1970 or something. But it's used for getting the current time. And then we add 60 seconds times the number of minutes remaining to find when this program should stop. We have our camera captures here. Camera.set is for the Raspberry Pi camera if you're using a Raspberry Pi. Otherwise, you can just use a webcam with the Jetson Nano using your computer's camera or like a USB camera. For this video, I'm actually using both a USB camera and my web camera, but my computer's camera is being used by Zoom right now, so I'll be using a USB camera for the demo. Here's the downloads for the haarcascades, which is the library, or I guess data for the facial recognition. So with these packages, it'll be able to tell whether what's in front of it is a face or not. And then it's imported to the camera, or not imported, but it's given to the camera. The data is given to the camera. Here are the constants for the number of faces spotted and the number of total faces, which is how the computer calculates whether you should continue spending more time in front of the camera, whether it's okay to spend more time in front of the computer, or whether you should take a break. Here's our while loop, which keeps the stream running while the current time is less than whatever the time you set it to. 20 minutes from now is the default. The camera will read what's in front of it, and then it will detect whether there's a face. If there is a face, regardless of whether there's a face or not, it will update. And then if there is a face, it will update the other counter and draw a rectangle for it and draw eyes for it. And then it will show your widget in a separate window, so you can keep track of it whether you want to, or you just like keep it hidden, and if you don't have to look at your face if you don't want to. Then we have a results analysis, which takes the data collected and compares it to what I think is the recommended usage time. I put it to 75%. So if you're in front of the screen for more than 75% of the time this program is running, then it will tell you to take a break. And it will also say that. If not, then it will let you continue on for your business. It will tell you how long you should take a break. I recommend 25 minutes if you're like me and have to use the computer a lot, because as you probably already know, I'm a programmer, and as a modding team, I sit in front of the computer quite a bit. But that's basically how the program runs. And then the computer will remind you through both a written message and a vocal message as to how long you should take your break if you have to take a break. That's with the Jetson Nano, but obviously not everyone has a Jetson Nano. So I did make a version which can be run on any Python editor. For this version, I use Google Colab, and I'll be going over with that. I guess I got a message, but that shouldn't be a problem. Let's continue on. Breaker Zero. Breaker Zero is the generalized version for everyone. This code was written on Google Colab because it was just so simple on Google Colab, and the GUI was easy. For the Jetson Nano, I used Visual Studio Code, and that took a bit more time because I had to install all the packages and make sure everything was in the right sections and stuff through the headless login. But I'll show that all in the demo. For this code, we have a lot more stuff to do, but that's mainly because the packages aren't directly installed, and like the widget, you have to create the widget. I did use JavaScript and HTML imported from Python. So the code runs in Python, but JavaScript and HTML are both imported. Here we have the generalized NumPy times CD2 as the same as in the other ones. These mainly are for creating a widget, the JavaScript image display conversions from base64. Let me just delete that. All right. And then we have our imports, same thing as the previous one, except with the stuff to create the actual widget. Here's our variable assignments. We have the number of faces as normal, the number of total pics taken as normal, as previously stated. We have our minutes running. The default is still 20 minutes, but on the Google Colab, I set the default for 2 minutes just for the demo. And then we have our functions. Here's a function to convert JavaScript to an OpenCV image, because Google Colab does not exactly support video and audio, but like if you program it to, it can. And then we have our video stream, which is a whole lot of code. But basically, just all this code starts a widget for displaying the screen, and it will display it. Here's our Python text-to-speech function, which we can use by just typing speak whatever I want it to say, and it will remind you. And here's our actual code, which starts the stream and then creates the widget. This is basically just the widget creation. And then it detects whether there's a face or not. If there is a face, it'll update the face counter. Otherwise, it'll continue just doing what it does, updating the normal number of pictures taken and displaying a stream. And then as for the results analysis, same as before, if you're in front of the screen for more than 75% of the time, you'll have to take a break for 25% of the time you spent in front of the screen, and it'll print and save that too. So the code itself isn't too complex, but creating the widget for a generalized version was much harder. And it does make sense because I didn't use a Jetson Nano, which was specifically designed for artificial intelligence. But of course, the Jetson Nano is much better for actually understanding how the code works, for if you're a student and want to learn. Otherwise, if it's just for general usage, then I recommend going with Breaker Zero. All right, that's the code analysis, and now I'll move on to a quick demo. Before the demo, I'd like to show you how exactly the Jetson Nano works, and I'll show that first.
All right, so here's a video of the Jetson Nano as promised. This is what a Jetson Nano looks like in case you didn't know. This wire here, the USB-C, is for the power supply. This wire is for the USB to mini USB, which connects to a computer, this wire. You can connect it to a computer. Just for like a demonstration of connecting it, I'll connect it to my Mac. We have our webcam right here, the USB webcam, which I did use in our actual demo. And then you can connect that through a USB port over here. And once you connect that, this right here is the Wi-Fi, so the Jetson Nano can be connected to the internet. And there is a flashed SSD card. You can find the flashing image on the Jetson or NVIDIA website, NVIDIA developers. And once you connect it to a computer, I'll just go ahead and just record on a computer like this. You can open up Visual Studio Code and open that up, or any code editor for that matter. And once you open that, I use Visual Studio Code because it has an extension which lets you SSH into it. This is called SSHing. It's basically connecting your main computer, host computer, to your Jetson Nano over there. Let me increase the brightness there. All right. So that's the Jetson Nano. I guess I could show you how to SSH. Terminal or CMD, whether you're on a Windows or computer, Windows or Mac. I was on a Windows originally, but unfortunately the battery's out. Like the battery is busted, so I'll be using a Mac for the demo. You type SSH, name of your Jetson Nano. I titled mine Shikori because I don't know, it's just a neat name I thought of, and I use it for a lot of things. And you type your IP, or yeah, your IP, and it asks you for a password. I type in my password, and it will SSH in. And then you can open Visual Studio Code, type in the password again. Right, and then you are into the actual thing, and you can see all your files on the Jetson Nano on your main computer. You can do the same through the terminal by just ls terminal commands. Yeah, you can navigate through it. Jetson Inference is probably the easiest way to use AI, but as I stated before, I don't have all the packages installed on this new computer because, you know, they were on my old computer, which is now busted. So that is how to use it. You can copy your code or import it from Git using git clone, and then whatever the package you want to clone is, the Breaker Nano. And then you can just run it on the Jetson Nano, but I will be using Google Colab for my demonstration just because, you know, simplicity.
I'll just run the code using this Google Colab link. So I'll copy it into another tab, and it should open up a Google Colab project. My computer is overheating from running so many tasks at once. But here's our project. First thing, it installs the right necessary packages, which aren't default installed into Google Colab. And then after that, it runs the same code as the code was in Breaker. So I will run this code, and it should start a video display at the bottom here. Yep, okay, let me move my camera. Yes. And basically, it detects a face in front of you. And now we just wait, continue on with our work. And when the program's done, when it's 2 minutes, it should remind us when to take a break. And yeah, it'll remind us to take a break and how long that break should be. So now we just wait. And we're down to the last 5 seconds of the program running.
It's time to get up and take a break.
So since I was in front of the camera the whole time, that was obviously more than 75% of the time. So it did tell me to get up and take a break, which I guess I could do. But I'm in this till the end, so let's continue this. Now I'll give an example of when it's not more than 75% and what exactly it does then. So I guess I'll stay here for until like 45 seconds, and then I'll disappear off the screen. So let's run the code again. Last 5 seconds.
You can continue on with your business.
Yep. So since I wasn't in front of the camera for more than 75%, even though I was in front of the camera beforehand, it says I can continue on using the computer because my break time was done. And yeah, that's pretty much a whole overview of my project Breaker. And thanks for watching.